Hello, it's an honor to be here. I'm Jisoo Lee from Busan National University. Before my presentation, I have a question for you. Do you remember your first patient? I believe that many of us may feel sorry for our first patient. But what if you could have the opportunity to practice using exactly same tests with patient? Would it have been better? Our research started with these questions. The title is Validation of Preclinical Practice of Tooth Preparation using 3D Printed Model and 3D Analysis for Dental Students. Let's begin with introduction. It's clear that there are ethical issues on student preclinical practice. It's because tooth preparation is irreversible. Even if we practice with artificial teeth, it's very different with actual patient oral condition. So, we would like to introduce digital technologies such as 3D printed models. Visualizing individual patient oral condition provides more realistic tooth preparation experience. Here are several limitations on student preclinical practice. It contains ethical issues, lack of preclinical practice, the need to develop and validate objective evaluation protocol, and the need to find an effective way of educating student preclinical practice. Let me elaborate this. As I mentioned before, ethical issues remain on student clinical practice. It may cause irreversible errors. Also, as a student only practice on standardized model, it cannot be seen that the students are getting enough practice. Secondly, student evaluation protocol is far from statistical analysis. Therefore, to develop and validate an objective evaluation protocol is needed. Moreover, we have to find an effective way of educating students. This is the objective of our research. We will evaluate the effectiveness of tooth preparation using 3D printed model and 3D analysis. Let's move on to the materials and methods. 30 senior students prepared full veneer crown on premolar or molar using 3D printed practice model. 3 repeated practice were made. 3D analysis of models were given to students after each practice. After this, students performed preparation on real patient. Total 4 prepared dies were scanned. The amount of axial reduction and occlusal reduction was measured. These are the methods. After scanning the diagnostic cast of a patient and designing by CAD program, practice models were 3D printed. 3D printed models were attached to mannequin phantom head. After tooth preparation, model was scanned. Scanned data were superimposed to visualize the amount of tooth preparation. Analyzed reports were given to students after each model preparation. From step 5 to step 8 were repeated 3 times. After 3 times of 3D feedback, students performed the preparation on actual patients. Then a definitive model was fabricated and scanned. Now, we obtained 3 surface files from the preclinical practice and 1 surface file from the actual tooth preparation. All files were properly handled and evaluated. In previous studies, the evaluation of tooth preparation was conducted by using photo, index, sectional view, or specific points of 3D surfaces. And sometimes, it was not sufficient to evaluate overall preparation with only certain sections or points. So, in our study, we utilized thousands of points from each test. The scanned data was handled and divided into occlusal and axial surface using mesh mixer. Occlusal surface was defined 1 mm below occlusal line angle. Axial surface was defined excluding occlusal and 1 mm of marginal area. The occlusal clearance was calculated from around 1,000 points, and the axial reduction was calculated from around 1.5 thousand points. The mean distance and standard deviation were analyzed by GOM-INSPECT. Results were statistically analyzed by SPSS. Let me explain the result. The first is the occlusal clearance statistics. There was no significant difference in the mean value between first and second preparation. However, there was significant difference from third preparation. Also, as the round progressed, deviation was decreased. The occlusal clearance should be in the range of 1.5 to 2 mm. As the round progressed, the reduction amount became closer to this range. The amount of axial reduction gradually approached the range of 1.2 to 1.5 mm. This is a questionnaire survey result. Students answered 3D model helped their preclinical practice on real patient compared to conventional model. This is satisfaction score of 3D model and 3D analysis. Most of the students answered satisfied on using 3D model. However, in a survey asking whether 3D analysis was easily understood, the answers varied. Next is discussion. When you ask me, what makes our research different, I want to say this. To my best knowledge, there are lack of studies in which subjected 4 times of tooth preparation with a patient-specific model. Also, we used 3D analysis as an objective evaluation protocol. Objective feedbacks based on statistical analysis were given. Next is what we found out. We confirmed that students who practiced with 3D printed models and received 3D analysis feedback improved their tooth preparation ability. Also, 3D printed model showed higher satisfaction than conventional model. However, some students found it difficult to understand 3D analysis. This may be because the students are not familiar with this. But I think there is a need for further research on digital color maps that are easy for students to understand. As you can see, the 3D feedback report can be shown in different ways. We are performing a further study to find out the most effective way of report for better understanding. Conclusion. We confirmed that using 3D printed model and feedback from 3D analysis can help student preclinical practice. Also, further study is needed on digital color map. Thank you very much for your attention.